Okay, so I'm actually going to demonstrate not only the principles of a 3-wire motor control or just control circuit in general, but also how an overload relay works with a motor starter. So you can see here I've got an enclosure set up. This is actually housing our motor starter and our auxiliary contacts, and we've got some indicator lights as well, and we have our start-stop stations over here. Now this is what I had on hand, so one of these buttons, in particular these open buttons, are not being used, but these are both normally open momentary push buttons, and these are normally closed stop buttons. I would like to go over the 3-wire control setup. Let's pop up inside this thing. So the point that I really want to make with this is that you can have as many start-stop stations as you want. The pattern really repeats itself. You just have to remember a few basic rules in regards to it. So as you can see, this is the start-stop station at the end of the line. Now, again, we're not using this one. You can see its terminals right there. These are the terminals for our normally open push button. These are the terminals for our normally closed stop buttons. Now, right here, our control circuit is coming in on this red wire. And you can see the purple and blue wires here are carrying it back to the coil. So here are the basic rules that you need to remember with a 3-wire control circuit. It doesn't matter how many stations you have, as long as your stop buttons are wired first. And they have to be wired in series with each other. So you can see right here where this comes in. It doesn't matter what side you come in on, as long as you have your wire coming in on one side and your wire going out on the other side. We follow that down here. Our wire comes in. And then we have here is our last stop button. At the last stop button in the series, we have to jump over to our first start button. This particular one comes pre-wired with a jumper. Most start-stop stations will have a jumper like that. So that jumper jumps to the first start button. The second rule we need to remember is that all of your start buttons, this includes the auxiliary contacts in the motor starter, they are all wired in parallel. So you can see right here with that jumper, we've got a blue wire we're going to have on one side and a purple wire on the other side. Going to our next start button, we have the same thing. We have our blue wire coming in and a blue wire going out. Same terminal, same side. Separated on the other side from the purple wires. They are paralleled as well. Make note of which one is hooking up to the end of the stop button. We want to be sure that the coil is not hooked up with the group that's directly in line with the stop button. Because as of right now, the voltage is available at this point and will not cross over to there and will not cross over to there until we press that button. Let's open up the enclosure here and see what the end of the line looks like. So I've got quite a bit of wiring in here that's actually facilitating these indicator lights. But we're just going to focus in on the blue and purple wires coming in that are going to create what's called our latch circuit. This is the key of 3-wire controls. Pay no mind to these other wires that are in here. Let's just focus on this blue and purple. Now, on a typical motor starter, you're going to have your coil right in the middle. These are the coil terminals. This one typically is going to be pre-wired outward going to the overload relay. So we're not actually worried about this. We just need to know where to connect that incoming power. Now remember that note that we made beforehand. We don't want the wire on the side that's connected to this last stop button or any of the stop buttons to connect to the coil immediately. We want that to stay broken. In this case, the purple wire was on the opposite side. So we brought the purple wire in on this terminal. This is a set of auxiliary contacts built in. You can see the terminals are actually split across here. This coil, when it goes and engages, it's providing voltage available here, here, and here across to those terminals here, here, and here, as well as here to here. These are all isolated from each other, all 4 of these. So these extra auxiliary contacts are built in just for this purpose. And they're typically labeled with a 2, and then we can see over here a 3. The purple wire was on the opposite side of the start button, so that's the one we want to hook to the coil. The voltage is already available at the blue wire from the start, so when this thing is on, it's waiting here to cross over. So if you've looked at my explanation before, you're going to see that when we energize this coil is going to stay down until we break that circuit with the stop button. So I'm actually going to leave this cover off. When I turn this on, this is actually key operated. When I turn this on, you might see these indicator lights come on. And then we're going to operate our start-stop stations. We're going to get the covers back on, and we're going to watch that coil go in and out. Let's just slide these on. Not going to screw them in place. Don't need to really do that. They're not going anywhere. But our indicator lights have just come on. We have voltage available at our start buttons, and we have our voltage available right here. And it's just waiting to go across. I've got this as an indicator light, but hopefully you'll see that that coil draw this in and out, and it's going to stay drawn in. I'm going to give a view from this angle over here so that you can see that coil draw that in and those contacts get made. And as a result, we're going to see this light go on. So we're going to hold it right here. You can see my finger in the back. And when I press this, here we go. We can see our lights on. I'm going to press stop, and it goes off. I'm going to press start again on the other one. We're going to see that coil's engaged. And when I go to press stop, we can see it disengage. So those are the basics of the latch circuit. How that works, why we use that, and we can put these all over the place. We can spread them all over a plant. Now this is accomplished much more easily these days with the advent of variable frequency drives and a lot of programmable logic controllers and such like that. But you never know when you might be in a facility that's still using an old method like this. And this basic control circuit is actually used in a lot of different sequencing methods. Multiple coils, multiple start-stop stations, and other pilot devices can actually work together to create a logical sequence and operation of things. So the next thing I want to show is what an overload looks like and how those overload relays work on the inside. We're going to turn this off now. Okay, so I'm going to use my screwdriver to kind of show, but you see right here, what I'm bumping right there, that's the bimetallic strip. You can see how nice and straight it is. So what's going to happen is when that current flows through, you can see that little catch that it's going through, it's actually going to bend and hit that little switch right there. I'm actually going to film this trip mechanism working. So I've got this little piece of wire right here, and we can see that opening. I'm going to slide it in that opening, and I'm going to pull it and pivot it in this direction like that. I'm going to pull it this way. So you can see over here, this is our trip indicator for the overload ring. I'm going to put it to the side. You can see that it's a recessed yellow tab. That's actually going to pop up whenever it's tripped. Now this reset tab right here is busted, but the button that I have on this enclosure is actually custom made to reach down into there. That will also pop up. And again, as long as that tab, that black tab at the bottom, is being held out of place, this will not be able to be reset. In this case though, the bimetallic strip's not going to hold. I'm just going to be putting this in there and trip it. Got this little wire slid in the hole here, so what we should see is this trip. So I'm going to pull up on this, and you're going to see that little yellow tab come up. There you go. You see that? Yellow tab. So this has come up as well. Now again, it's not going to be able to be reset normally, but when that time comes, a reset button is really just a spring-loaded button that's got a little metal arm or plunger on the end of it that's made to touch right into that. I've made mine on my enclosure custom, but for this case I can just use the screwdriver, and you're going to see that yellow tab go back in. So now it's reset and ready to go. So now let's do a demonstration where we can actually see if we see these bimetallic elements heat up and trip it naturally. Okay, heat gun plugged in. Coil ready. I'm going to turn it on. There have our indicator lights. I'm going to close the circuit. So that heat gun should be, I'm going to go ahead, turn it on high. So that heat gun's going to draw a good bit of current here. We're going to watch this from the side. At that point, we should see the trip indicator pop up whenever it's nice and hot, and we'll see that coil release. There you go. The overload has opened up the coil. You see the trip indicator right there. And if I come in here right now, that bimetallic strip is going to be so bent, I am not going to be able to reset this. See that right there? It will not reset. I gotta wait for it to cool down. There's no voltage there, but I'm putting my finger, just laying it across here, not on it, and I can feel it's pretty warm still, even after a few seconds. See that doodad in the back? Looks like it's being held forward a little bit. Not quite. Oh, it's almost cool enough. Let's give it one more shot. Here we go. I can turn it back on. Light's green. Our little indicator light is on. We've eliminated the overload and it's gonna go.